I believe you're doing really amazing, and welcome to this first Principal Thinking YouTube channel. And this is part 3 on permanent magnet material. In the last part, we have given an answer to this question: what is the atomic origin of magnetism? And the answer is net magnetic moment caused by unpaired spinning electron. Let's say you take a bulk material, and if it is producing a net external magnetic field, then magnetic moment of every atoms has to align in the same direction, which is like this, and then it is going to produce a external magnetic field. Now let's say if I have unmagnetized it, and then I would like to ask a very basic question: how the magnetic moment of atoms are aligned in unmagnetized ferromagnetic material? And if I think very intuitively, then it is going to be something like this in the random fashion, in a such a way that net vector sum of this magnetic moment is going to be 0, and hence the net magnetic field outside this magnet is going to be 0. But wait, this will not be the case. Let's start figuring out what is going to be the final state of unmagnetized material. Let's start from the magnetized state of the material, where all the atoms are aligned in the same direction. And now if I have been given a task that you can rotate every atoms in such a way that you can bring down the next external magnetic field to the 0. And what I will do, I will start blindly rotating every atoms in such a way that I will make sure that the net magnetic moment is going to be 0, and hence the net magnetic field outside the magnet, it has to be 0, and it will be something like this. But wait, they are going to be the smartest way. What I will do next, I will pick only top half of the atoms, and I will just rotate opposite to the bottom one, and let's see what is the magnetic field outside this magnet. You will observe that we have drastically bring down the external magnetic field, but still there are going to be a magnetic field near left edge and the right edge, which will look something like this. And to witness this, if you bring the compass near to the left edge or the right edge, you will see it start deflecting along this field line. Now to even make this external field 0, what I will do, I will pick few atoms near left edge and the few atoms from the right edge, and I will arrange in this fashion, which you can see here, right? And now the magnetic field outside this magnet became 0, and hence now see that the effort required in this process was much less than compared to what I was doing blindly, where I was rotating every atoms randomly. And don't you think that the nature works in the same principle? Nature always try to minimize the energy, they always try to minimize the efforts. And if you think from the minimum energy principle, this is going to be the ideal state of unmagnetized material, where the bulk materials are divided into the small region, in other words the small domain, where magnetic moment of every atoms in that domain is going to be in the same direction. And if you add the vector sum of the resultant magnetic moment of all the domains, it's going to be the 0 for unmagnetized magnet. Now you will say that from the minimum energy principle, it is going to be this state. But can you do some experiment to prove this? So let's start doing an experiment. Let's take a coil and then connect both in the coil into the amplifier, and then finally connect the speaker to the amplifier. Now if you change the magnetic flux inside the coil, it's going to produce a voltage, and if you amplify the voltage, you are going to hear the noise. Now bring the electrical steel strip inside the coil, and now also bring the magnet bar here. Now let's assume that the atoms inside the steel strips are into the random fashion, which is something like this. Now if you bring the magnet nearby the steel, what will happen? Individual atoms start flipping, and hence there is no considerable change in magnetic flux inside the coil, and it will not produce any noise, or it will produce a very less noise. Now consider the second case where the steel strips are in the domain phase, right? Like this, as you can see here. What will happen in this state, when you bring the magnet near to this steel strip, entire domain try to flip, and there is going to be drastically change in the magnetic flux in the coil, and you will see the click noise, or very loud click noise. You are not going to listen a small noise or no noise. You are always going to listen a high amplitude click noise. And to witness this noise, you can go to this YouTube videos. I have already put the description of this video inside the description box. You directly jump to this time, 29 minutes 19 seconds, and you start witnessing the noise which I was talking about. And hence, if I have to ask the same question, how the magnetic moment of atoms are aligned in unmagnetized ferromagnetic material, so definitely it will not be in this state because it requires high energy. It's going to be in this state because it requires minimum energy. Now in the next part, I am going to discuss about the intrinsic property of permanent magnet material, which is magnetic moment per unit volume. So let's stay tuned, and meanwhile, if you're liking this content, please give a like and subscribe.